In this lesson, I want to show you the completing the square method for solving quadratic equations. And not only are we going to use this method to solve quadratic equations, but we're also going to use this at the end of this lesson to help us to change standard form quadratic equations into vertex form. So let me just get started here with how do we use the completing the square technique. Notice my note here off to the right. Very important that you observe that the quadratic equation must be set up in this format before you can even begin the completing the square process. So that means that my constant, in this case -4, needs to be moved to the right side of this equation. Of course, we're going to need to add 4. And I also observe the a term, the number in front of x squared, is +1, so I'm good there. But before I can begin completing the square, I need to do this real simple step of moving the constant to the other side of the equation. Okay, so underneath my equation that I have written here, I'm just going to make a little quantity squared. And inside the parentheses, I will always do the square root of the first term. I will do the sign, whatever this next sign is. If that were minus, I would put minus here. And then a very important next step is whatever the linear coefficient is, I need to divide it by 2. Always dividing the linear coefficient by 2. And 4 divided by 2 is 2. Okay? Now, looking at the number in the parentheses, 2 squared, I'm going to be adding 2 squared to both sides of this equation. What we have just done is we have created what's called a perfect square trinomial, which is this trinomial here. And the way this trinomial would be factored is x plus 2 quantity squared. So that's where completing the square got its name. We need the number that would be required to create what is known as a perfect square trinomial. And the factoring of that perfect square trinomial then is provided for us. All right, so on the right side of the equation, I'm going to do 4 plus 4, which is 8. To solve for x, my next move is to do the square root of both sides of the equation. I always include plus minus whenever I do the square root of both sides. That makes this 2 go away, and I'm left with x plus 2 equals plus minus, and I need to simplify the square root of 8. And just remember our review of simplifying radicals. That would be plus minus 2 root 2. And then my final step to solve for x is to subtract 2 from both sides. And my answer, my two answers actually, because remember, I'm going to find 2 solutions. My 2 solutions are x equals -2 plus minus 2 times the square root of 2. All right, I'm just going to show some more examples of this. I need to first add 1 to both sides to get this started. Now I'm going to use completing the square. Square root of x squared. Bring down the sign. Always divide whatever the linear coefficient is by 2. 2 divided by 2 is 1. -1 squared is 1. So I'm going to be adding 1 to both sides of this equation. 1 plus 1 is 2. Doing the square root of both sides gives me x minus 1 on the left side. And of course, on the right side, I'm going to have plus minus square root of 2. So we'll just go up here and finish this off. My final step is to add 1 to both sides of this equation. And there are my 2 answers. That was easy enough. All right, similar deal here on my third problem. I'm going to subtract 36. All right, set up my quantity squared, x minus 8 divided by 2, which is 4. -4 squared is 16. So I'm going to be adding 16 to both sides of this equation. And when I add 16 to negative 36, I get negative 20. Square root of both sides gets me x minus 4 equals plus minus. And I'll show the square root of negative 20, but we remember how that simplifies using the number I. That would be 2I square root of 5. Okay, just a review of our previous lesson. And then one final step to solve for x. 4 plus minus 2I square root of 5 is my two solutions. All right, very good. Okay, let's try number 4. This is pretty much already set up. The constant's on the right side of the equation, so I'm going to make my quantity squared. X plus 6 divided by 2 is 3. 3 squared is 9. So I'm adding 9 to both sides. Gives me negative 25. Square root of both sides of the equation. And once again, I'll show this, but we need to simplify this radical using the number I. And the square root of negative 25 is 5I. And then the final step of subtracting 3 gets me to my 2 solutions. Okay. Number 5 is a little different because notice I've got a coefficient greater than 1, and we said that it has to be 1, and the linear term needs to be moved. So those 2 steps need to take place before I actually complete the square. So here I've moved 3x over to the left, and now to make this linear or quadratic coefficient be positive 1, I'm dividing everything by 2. And that's going to give me x squared minus 3 halves x equals negative 2. And I think I'll go to a new screen and finish working this out. But hopefully you understand how we got to this point. X squared minus 3 halves x equals negative 2. All right, so let's make our quantity squared. X minus, and this is a little tricky in the beginning, but it's not too bad. We're still dividing by 2, but 3 halves divided by 2 is the same thing as 3 halves times, times 1 half. So what happens when you divide these fractions by 2 is essentially you're only multiplying the denominator by 2. So 3 halves divided by 2 is 3/4. So just think of multiplying the denominator only by 2. All right, so now we look at negative 3/4 squared, and that's 9/16. I'm adding 9/16 to both sides. Well, I'm going to look at negative 2 as negative 32/16, so that when I add these fractions together, now they have the same denominator, and I'm now at the point where I have x minus 3/4 squared equals negative 23/16. Okay, just combine these two fractions. Square root of both sides. All right, and if I do the square root of a fraction, I'm really doing the square root of each number separately. Okay, so I'm probably showing a little bit more than is required, but I just want to make sure you see how we simplify this radical. So the square root of negative 23 is I times the square root of 23. And then jumping down to the bottom, the square root of 16, of course, is just regular 4. And so now we're ready to solve for x by adding 3/4 to both sides. And we get our final answers. Okay, so we're done with that. Okay, let's try one more. it's ready to go, except all the terms need to be divided by 2. So that gets me to x squared plus 7 over 2x equals 1/2. All right, set up the quantity squared, x plus, remember 7/2 divided by 2 is just 7/4. Just multiply the denominator by 2. And 7/4 squared needs to be added, really to both sides, but in this case I'm just going to show it on the right. 7 squared is 49, 4 squared is 16. All right, if we think of 1/2 as 8/16, and we add that to 49/16, that's 57/16. Square root of both sides. And once again, just think of the square root of each number separately. All right, we can't simplify the square root of 57, but we can simplify the square root of 16. And now we're going to subtract 7/4 from both sides. And we are final answer. Here we are. Okay, there's our answer to that example. All right. Well, in my opinion, the major reason for understanding completing the square principles is so that we can change standard form equations into vertex form. And we've looked at vertex form already. This is just a little review. If you're looking at vertex form, these numbers in place of h and k represent the vertex. So let me show you how we can take standard form, which is given here in number 7, and change it into vertex form. And what I'm doing here with these two problems will be the same thing that you will do for problems 28 and 31 on your homework. In the beginning, it's just like we were doing before with our quantity squared. We do the square root of x squared, bring down the sign, and we divide the linear coefficient by 2. Okay, we also look at this number, -5, and square it, and we get 25. But here's where things change just a little bit. I'm just going to go back up to my standard form, and this 25 that I got, -5 squared, I'm going to subtract. Always subtract. Okay, subtract from standard form, and then these two constants on the end, -2 minus 25, can be combined. And it's as easy as that. We now have vertex form. And I'd like for you to go ahead and include with that what is the vertex. So the vertex in this case would be 5, -27. Okay, let's take a look at another one. And these ones where the a term is just 1, these are pretty simple. Okay, shouldn't be too bad. All right, square root of x squared, bring down the sign, and then 5 divided by 2. So think of this number squared, 25/4, and subtract it. Just go back up to your standard form and subtract this number squared. All right. So remember, 3 is the same thing as 12/4. And if you take 12/4 and you subtract 25/4, that's -13/4. So that's our vertex form. So our vertex is -5/2, -13/4. Okay. This one's a little different, and you'll see one like this, or two problems like this on your homework. The only difference really is our coefficient for x squared is -1. Well, we learned when we complete the square that it has to be +1. So I'm going to suggest this. Let's just temporarily make it become +1 by either multiplying or dividing both sides by -1. Okay, so notice how all the signs changed. And now I'm going to go through my routine just like we did before. Square root of x squared, bring down the sign, divide 8 by 2. Okay, and remember this number squared, -4 squared is 16, gets subtracted. So 10 minus 16 is negative 6. All right, now I'm going to put it back into regular vertex form, which means positive y, so multiply by negative 1, and it puts our equation back into vertex form, our final answer. So our vertex would be the ordered pair for 6. Very good. All right, one more, and in this case, the lead coefficient, the number in front of x squared, is positive 2. Well, in a similar way, I want to make this become 1 just temporarily so that I can complete the square. So I'm going to think about multiplying everything through by 1/2. So that's going to make this positive 1x squared. It's going to make this minus 4x, and then this would be 13 halves. I just multiplied both sides of the equation by 1/2. Okay, and let's go through our process. Square root of x squared, bring down the sign, 4 divided by 2, negative 2 squared is 4, and I'm going to subtract 4 from my standard form. Okay, now remember, I need a common denominator, so I could think of 4 as 8 over 2. So 13 over 2 minus 8 over 2 is 5 over 2. All right, and now I need to set this so that it's solved for y, so just think about multiplying by 2 on both sides. 2 on both sides, and this will get us back to our vertex form final answer. And if I multiply 5 halves times 2, I get just 5. Okay, 10 over 2, which is 5. And the vertex would be the ordered pair 2, 5. Okay, so that wasn't too bad. Just a temporary adjustment so that we can go through this little completing the square process, and then we'll put it back to get to our final answer. So I hope these examples help you, and you saw the assignment. It's on RenWeb, and so work hard on these. Let me know if you have any questions.